Hi guys, Darren here, Maths Guru, and you are watching this video on rearranging the simple interest formula, part of this maths course for financial maths. Really good to see you. Thank you very much for dropping by. If you haven't already done so, please subscribe to my YouTube channel. Just shows me you're watching, or at least someone's watching, not my mother. And if you head over to MaffsGuru, you get these videos, downloadable notes, time codes, and so much more. Now, this video is continuing from a previous stream. We've looked at simple interest, we've looked at the language for percentages and markups and discounts. And we're just going to continue powering through. I think this course is absolutely freaking awesome because it is so real world. What is our learning objective? Well, we're going to recap what simple interest formula was. We've met it in the last video, but you may have had a break. We're going to recap how to rearrange the formula to transpose. Also, another video. Whoa! Notice how this is building on all my previous videos. And again, they're available with downloadable notes from MaffsGuru.com. Why don't you just stop this video now, head over there, sign up, totally free, download the notes, and then at least you can scribble all over them and you can add the stuff that I may not put down. And then use the knowledge to transpose the simple, and I think I should say interest formula. I'll change that for the notes. All right. What does transpose a formula mean? It means to change the subject, i.e. to make a different letter on its lonesome on the other side of an equal sign. And to give you an example, if we had the formula S equals U plus 18. Don't worry what that is, it's actually a constant acceleration formula. But we want to make U the subject. Now what that means is get U on its own. How do we do that? Well, anything that's connected by a plus or a minus can effectively just be got rid of, or we're going to subtract it. Now remember, between the A and the T is a kissy, but not a problem, because what I'm now going to do is take away AT from both sides. That goes, and it leaves mu U is equal to S was already at the front of the Q, and so it stays at the front of the Q. Now what I mean by that is the S just moves along and the AT is there. Normally we'd write that in the other way around, so we say U is equal to S minus AT, and ladies and gentlemen, I've now made U the subject of my formula. And I could have done that with any other way of doing it as well. Yes, we can make T the subject of the formula. I'm going to do it by hand first and then remind you how to do it on the CAS. So S is equal to U plus AT. Now in this situation, the A and the T are stuck together, leave them alone. I'm going to get rid of the U first by subtracting U from both sides. Now the S was already there, so S minus U equals AT. Now on the T on its own, what's between the A and the T? Kissy, yup. So that's S minus U equals A times T. If you have no idea what I'm talking about, kissy, where have you been? Watch all my other videos. All right, think of that as a kiss. So what I want to get on its own, the T, so I need to get rid of that times by A, which means I'm going to divide A on both sides. Now, because I've already got two things there, that has to stay, and I do a divide sign by the A equals T. All right, so I divide both sides by, or the whole thing by A, and normally we write it the other way around as S minus U on A. Now we could have split that up, and that's also the same as T is equal to S on A minus U on A. But not necessarily important for this particular video. So there you go, T equals S minus U on A, ka-ching, that's by hand. How do we do it on our CAS? Well, ladies and gentlemen, exactly using the solve function. The TI Inspire is what I'm using at the moment. Sorry, Casio ClassPad. My school doesn't currently use it at this moment. So solve V equals U plus AT, comma T. Now remember, when you put these formulas in, you have to do, V is equal to U plus A times T. If you just put AT into your calculator, it's not going to work. Trust me, give it a go. Your calculator gets confused because it doesn't realize there is a times between them. It actually, funnily enough, reads that as the word at. Very weird, but it's just a dumb piece of machinery. Then you put the comma T because we want to solve it for that, and obviously you enclose it in a solve. Now what you notice there is you get the answer as T equals minus U minus V all on A. Is that the same as I got before? Believe it or not, yes. I don't know why the calculator does it this way, but you'll also remember from the previous video, we have this prop frac thing, which can actually take the fraction you've been given, put it inside a set of brackets, and it splits it up that T is equal to V on A minus U on A, which funnily enough is what we got the previous slide. So sometimes doing it by hand makes life a bit easier. Right, so what was our simple interest formula? It was a way of working out the interest we would get on a fixed amount of money over a period of time at a given rate of interest. All right, so we had I is equal to P RT on 100. There we go, right? But what if that's just giving me the interest? What if they actually gave me the interest and the rate and the time it was in there and asked me to find the principal? Can't at the moment. Well, we could if we transposed the formula. Now, obviously, we can do it by hand or we can do it by CAS. So let's get the interest rate first. So let's transpose it 3 times. The first time I'm going to find my value of R. Now, just so that we all know, there it is already for me on the CAS calculator. But what I'm going to do is do it by hand. So I is equal to P RT on 100. So the first thing I want to do is get rid of that divide by 100. It's a bunk bed. Get rid of it. So we end up with 100 times I equals P RT. All right, so I'm going to times by 100 on both sides. Gets rid of that, which gives me 100 times I equals PRT. Now, what we know is 1 times 2 times 3 is the same as 3 times 2 times 1, which is the same as 2 times 1 times 3, and I could go on. But when things are all connected by kissy kisses, we can actually move them around. And you're going to say, well, why would I do that? Well, I want to get the R first. So I could have R times P, and I'm going to write it T. Now, why am I doing it like R times PT? Because I want the R on its own, which means I need to get rid of that times PT. How do I get rid of a times? Divide both sides, that's right. So I'm going to divide both sides by PT, divide both sides by PT, which gives me that R is equal to 100 times I on PT. And is that what my calculator got? I should go. So now we have a formula. R equals 100I times PT. Transpose the simple interest formula, finding the time period. Same, we want to get T on its own. So we have I is equal to P RT on 100. What's the first thing I want to get rid of? Because I want the T on its own, that divide by 100 has to go. So I'm going to multiply both sides by 100. That's just going to give me the PR, and I'm going to write the times by T there. Now, why am I going to write the times by T there? Because I want it on its own. So I could, like in the previous example, put T times PR and say, well, I want to get rid of that times PR to give me 100 times I equals T. How am I going to get rid of the PR? I'm going to divide both sides by PR. Is that what my calculator came up with? 100 times I divided by PR. I should go. Thank you very much. See how this is all working? And finally, we can do exactly the same thing here by giving the principal. So we have I is equal to P RT on 100. See if you can work it through with me, but get there first. Yep, want to divide by 100, or get rid of the divide by 100. So I'm going to times both sides by 100. So it's going to be I times 100 is equal to, what do we want? P times RT. Notice why I did that? Because I want the times by RT to go to the other side. So just to write it again, 100 times I divided by RT is equal to my principal. Easy peasy lemon squeezy. All right, now, there is another way of doing this thing here if I want to find the principal given my initial amount and the rate of interest or time. Yes, now this looks gross, yes? But what it's basically saying is it just gives us the final amount of the investment without having to do 2 different calculations. Me, I prefer to do 2 different calculations. I'd much rather find the interest first and then add it on. But anyway, let's not get too wound up on this. We can use that formula. Put it in your summary book. It's up to you to decide if you want to use it. So find the rate of simple interest if a principal of $8,000 increases to $11,040 in 4 years. So I'm just going to use, what does it want? To find the rate of interest. So in this situation, it wants R. So I'm going to do 100 times I divided by PT. So 100 times by I, which was, how much interest did we get? Remember, we can work out the interest, because if we know the final amount and we know the principal amount, we can take them away. So I now know subcalculation interest is equal to 11040. We're going to subtract $8,000 from that, which is going to give me 11040 minus 8123 gives me $3,040. Now you're probably wondering why I'm using a calculator. I hate making mistakes on these videos because it's too hard for me to go back and redo them. So I'd rather use the calculator and make sure I get it right. So in that situation, times that by 3040 divided by the principal, which is $8,000. They gave it to me in the question, and times by the time in years, which is 4. And again, let's see if I can make this simpler. So that gives me 304 divided by 8 times 4, 8, 16, 24 is 32. All right, and I could do that, but I'm not going to. 304 divided by, try that one again. 304 divided by 32 gives me 9.5. Now is 9.5 my answer? Nope, because we want our rate of interest, we've got to make sure that we put percentage, so 9.5%. And here we have a second example, same idea, but a principal of 5,000 increases to 5,500 in 9 months. Do you see the trick? Hopefully. So let's go back and do the same thing here. How much interest did we earn? Well, we went from 5,500, we ended up at 5,500. We started with 5,000, which gives us a $500 interest. Same. Okay, so we know that rate is equal to 1 is I times 100 divided by my principal, which is in this situation 5,000, times by, now time in this situation is 9 out of 12 because we've only got 9 12ths of a year. Right, let's see. Oh, that I could have actually got rid of and put in there 500. Let's see what we can do. 0 crosses off of there, 5 crosses off of there to give me ones. So what do I end up with? I end up with 10 divided by 9 12ths. That is the same as 10 multiplied by 12 on 9. So 120, oops, he says 120 divided by 9 gives me 13.33. 13.33, and again, percent. Now, because in this situation they didn't give an accuracy, I'm just going to round it to 2 decimal places, but always make sure you check for the accuracy. Second example, find the length of time. Now we're going to use t. So we've got t in this situation is 100 times I divided by p r. So they've got to give me all this information in the question. Find the length of time it would take for 5,000 invested in interest rate of 12 to earn $1,800 in interest. Okay. So t in this situation is 100. Do we have all the information? Do we have the amount of interest? Yes, 1,800. Do I have the principal? Yes, 5,000. Do I have the rate? We do. It's 12%. Oh, lovely. So a 0 and a 0 cross off of there and there. 1 0 can cross off there. All I'm dividing by 10 on top and bottom. So what do I get? I get 180 divided by 5 times 12, which is 60. And I can do that in my head, which gives me 3 years. Now remember that this is years, so 3 years. Thank you very much. Be careful when we get decimal values as well. I'm going to show you in a moment. Yes, and it says give answers in days to the nearest day. Now in this situation, when I've looked at the question in the Cambridge General Maths, they wanted this one left in 3 years. The next one's going to be a decimal. So that's the one they wanted it in the nearest days. I'm going to show you in a moment. Right, so again, same idea. What do we want to do? We want to find the t equals 100 times I divided by PR. So 100 times the interest, which was 404, divided by the principal, which was still 5,000, times by 12. Okie dokie. 2 zeros knock off there, 2 zeros knock off of there. I don't think I can do anything else. No. So that's going to be 404 divided by 50 times 12. Let's put that into my calculator. 404 divided by 50 times 12 gives me 0.673 reoccurring. So 0.673 reoccurring, but that's in years. So I think this is where the question now wanted you to say, well, hold on a moment, can you write that in days? Well, how many days are there in a year? 365, really 365 and a quarter, but we won't split hairs. So in which case, if we wanted it in terms of days, we're now going to do the fraction of the year, 0.673 reoccurring. That just means I've got 3, 3, 3, 3, 3, 3, 3, 3, 3. And I'm going to times that by 365, because that's a fraction of a year times the number of days. Now, I'm not going to put 0.673333. I've already got that value in my calculator, so I'm just going to say answer times 365, which gives me 245.7666 reoccurring again. And because it wanted to the nearest day, 246 days is going to be my answer. Yeah, so these questions are easy in the sense of it's an easy formula, but we have to think about what answer they're giving. And the final two examples, find the amount that should be invested in order. So now we're going to find the principal. So we're going to do principal is equal to 100 times I divided by R times T. All right, find the amount that should be invested in order to earn $1,500 interest. Thank you, 3 years. Yes, interest rate of 5%. All right, fine. So in which case, we're now going to say the principal is going to be equal to 100 times the interest, $1,500, divided by the rate, which is 5%, times by the number of years, which is 3. Okie dokie. Well, 5 times 3 is 15. So they go into there, which gives me 100 times 100, which gives me $10,000. Yay! Moving on to the last part of this video, find the amount that should be invested at an annual interest rate of 5% if you require the value of the investment to be 15600 in 4 years' time. Hold on a moment, they're being sneaky there. All right, so 15600 in 4 years' time. Now in this situation, we can't use that formula. Why? Because we don't know how much interest has been given. Yeah, so while we've been given a rate and a time, we haven't been given just the interest. We've been given the final amount. And that's where we actually have to go back to that other formula in the very end of sort of the chatty bit. So that's that formula there, where A is the final amount we end up with, R is the rate, and T is the time. And I have all of that information. So my final amount was 15600 divided by, open brackets, 1 plus rate is 5 times the time in years is 4 divided by, that should be 100 by the way, 100. Closing my brackets is equal to, and I'm just going to bang that into my calculator, and out comes $13,000. So in that situation, how did I know which formula to use? Well, because none of the, or one part of the simple interest formula was missing. And that was where my brain went, hold on a moment, something's not quite right here. And I went, they've given me my final amount, which meant I could use this formula here. All right, guys, I'm done. Thank you very much. Hopefully I'll see you in another video. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is MaffsGuru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye-bye. Stay safe.